Oh, Faiz, I just sent you. Yeah. Okay, this one is full screen. Testing, testing, testing. Okay, so let's get started. So hello everyone, welcome to this evening here today. So today we are really pleased to have Orkun from Citrea. Let's give him a round of applause. Yeah. We'll do that later.
Okay,
I'll just do a round
start.
up first. Yeah, my bad. Okay. Yeah. So before we start, this is like the brief agenda that we have today. And next, we're going to have the main subject from Orkun, pushing the limits of Bitcoin with ZK Rollups. And then after that, we're going to have Q&A. And then we're going to have pizzas after the Q&A. Yeah. So just like this one is, shout out to APU for sponsoring this event as well. Let's give them a round of applause as well. Yeah, speaking about APU, so this Friday they're actually hosting, if you're curious about learning domain names, not exclusively in Ethereum. This is not Ethereum, but if you're curious, you can also like join. It's on the same venue this Friday, 6 p.m. to 9 p.m. Auditorium 7. And yeah, you're interested, you can reach out to the folks over there or you can scan this event. Okay, next. Okay, so I know that recently there's a lot of events going on. ETH Global, Token 2049. So like these are the teams, two teams that that recently participated and won like 2 bounties each. So the first one is actually Daiwei, and the next one is Mofo. So Daiwei won 6,000 bounties, not to compare, just for context, Mofo win like 3,750 bounties. And so so these two teams are actually mainly students from Ta UMT and Taylor's. They also have their own blockchain club, by the way. And yeah, do we have members who are part of this team? Oh, okay, okay. No, you're Mofo, right? Okay, okay. So would you like to give a brief sharing Right now it's fine. Yeah, yeah. Okay.
Yeah, hey everyone. I'm not a student, by the way. Yeah, I've graduated already. We went with, there's actually three of us. I'm from APU, used to be from APU, and then APU. The rest of them are from Taylor's. We built a vibe dating app. Essentially uses a brainwave device that's from OpenBCI. It measures your emotional signals and takes that, um, and then it merges together with like social media MCPs to determine your topic of interest. It uses that data to create an AI agent that represents you, maybe at least 65% of you, and goes and dates with other AI agents to determine the best match possible. And you and the other AI agent essentially, if let's say you like the proposal that the AI agent gave, they say it's like, hey, this is the person that you might like. You confirm that. A certain percentage of funds from your AI agent and the other AI agent will go into a escrow smart contract to stake, and so that you guys will actually turn up for the date. A lot of people loved the idea. I think there was about 50 hackers who came and asked, what are we doing? Just because they saw the brainwave thing. It's actually outside, so later when you guys are having pizzas, we do like a short demo. But yeah, so we'll most probably continue the idea. So a lot of sponsors who also asked us to like build on them and stuff like that. But yeah, that was what Mofo built. I hope that makes sense. Yeah.
Thank you, Yudish. So the next part is also a similar slide, but this one is in token 2049. So these two teams are quite the similar people. But only thing that I want to highlight is that TT, which also some members from, I think some members from the Daiwei, they actually won the top 5 finalists. And what the top 5 finally get is, I think they are like they have an access like an expressway to the accelerator program in San Francisco, I think. Of the like the people who host this event. I'm not too sure, but yeah, I think that's all for my part. I'm going to pass it to Wen Kang to share about the monthly roundups. Over to you, Wen Kang.
So, hi, I'm Wen Kang. This is the first time I'm giving a monthly roundup here. Yeah, hi. Hope you are having a great evening, great start. So let's start with the money round. So first, in the real world, um, the Intercontinental Exchange just invested 2 billion on Polymarket. So gambling is now an invested industry. Go gamble. Not financial advice. Okay, so ICE is a parent company of New York Stock Exchange, and yeah, so it's to become Polymarket's investor globally. So yeah, you can check it out. I'm not sure how regulation deals with this, but yeah, it's still legal for now. Okay, great. So on tech side, Fusaka upgrade is coming. For those interested, there's a bunch of things. I'm just gonna cover a few highlights. So first of all, the blocks are being scaled. PeerDAS, it's part of Fusaka. It's gonna use DA sampling to essentially increase the amount of blocks you can store by distributing them across a lot of nodes. L1 is being scaled by a lot of tweaks with the parameters for gas limits, gas caps, etc. And history expiry is now, there's more progress towards it. It's actually been implemented, I believe, in the previous update upgrade as well. But here it's upgrading one of the receipts. I think it's related to P2P receipts. So yeah, it's more of a point to remind all the clients to start implementing history expiry. So yeah, UX upgrades. This is quite interesting. So they are actually EIPs that support deterministic. I believe it's deterministic. Look forward to proposal. I think validators. I think block proposal. Yes. So that will help with pre-confirmation, and also it's SECP 256R1 pre-compiles are being added, which will help support anyone that wants to use passkeys or device native signing. So the things you are familiar with, using your fingerprint to like sign signatures and all that. If you want to use that for a wallet, it might be easier now. So since you can use the pre-compiles. So yep, quick update on Fusaka. So yeah, they are trying to scale. So Okay, so money round of DeFi. So if you are interested in perps, if you're interested in perpetuals, Binance family of perpetuals, decentralized perpetuals, Esther, recently got into a little bit of a drama. Essentially, their volume is 10 times hyperliquid. And it's getting weird. So DeFi Llama decided to take it down from their site, which which is followed by a lot of discontent user of Esther, which points people to the Dune. And that Dune page that they point to actually uses DeFi Llama API, so it's the same place. But yeah, the volume is about, so I think it's 80 billion to 7 billion of hyperliquid, which is a bit weird. But yeah, so that happened. And finally, some local news. So a company called Facet got Labuan approval. Labuan FSA approval to launch stablecoin powered digital bank. I don't know much detail, but good news, I guess. Stablecoin seems to be in stablecoin season right now. So everyone is trying to launch their own stablecoin, perhaps to lock some liquidity in their own ecosystem. No speculation, no. Maybe you can check out why what's happening, and yeah, it's just interesting that this is happening right now. Although stablecoin has been there for so long, USDT, USDC. Now everyone wants their own stablecoin, and maybe there's a reason. So yeah, that's essentially, I think, my part of the job done. Oh, anything else? Oh, okay. So yeah, that's essentially it from my side. Exciting news here and there. I'll pass it back to our host.
We're going to take a 5-minute break, so to see if we can repair the other screen. Okay. So just stay still for a bit. Okay. Very, very quickly. Thank you, everyone. Oh yeah, by the way, so there's actually some Citrea swag right over at the corner. They are hats. So if you want one, just take this time to get. First come, first serve, I would say. Yeah, it's at the front.
so over the roof that we didn't get money. How many? It was about 1,200 hackers. Orkun was poorly organized, but I don't know how still won. I got it. This HCD. They gave me accommodation, and also they wanted my HCD ticket, so I just had to pay for flights. 8,000 ringgit.
So is it my
Yeah.
my laptop?
I think so. One of the reasons could be it's like, first of all, it's through the Docker. Like, I think this hub.
Oh, okay, okay. But I think it's fine. We can just stick with that one. Yeah.
Because it is like detecting, but then it's not displaying.
Oh, I see, I see. I see, I see. But I think it's good lah. I think we'll just
Use that.
yeah, use that one for now. Okay. Thanks, man. Thanks, man.
Just I will confirm it's.
Yeah, then I talked to Angela yesterday. Oh yeah, Angela is the one. Yeah, so we're gonna try to
The Mac should work because we have lecturers as well who use Mac, but it mainly is this thing.
I see, I see. Interesting.
Then I was like, put typo, put typo. I was like, okay, just run out of how many weeks? 6 weeks. 6 weeks.
Oh, the payments, is it also that is actually, I go through all their all is Spanish.
Same. And most of the time zone is including in our middle, so I'm like, man, I just want to focus on
They really give you
He's one of the 19 teams.
because I have a
where is it?
see that?
Try if it's.
Does it matter, or does it matter if I use this one?
You try. You can try. Let's see.
I don't think it's good.
Because I said it's detecting, but hello.
I think we focus on hugging bases style.
For one thing I wanted to ask.
So we are in base batches 001 BD. So we are taking to
No, it's fine, it's fine, it's fine.
enter base batches 001.
Maybe you can try some settings in the Mac.
Yeah. This is. Yeah. I know. Okay, thank you very much. It's not appearing. We'll set up again.
This is the 19 things that you see.
Send it to you.
Mine, and after that, mortgage.
Okay.
It is mainly because of the thing. So because of the Mac. Okay.
Alright. All good. Thanks, man.
I will keep this.
But this one macam it's more like a program that
It's not
they
showing, right?
just like give you support. If you reach the TKTVL, they give you like some grant. Yeah.
I haven't seen the TVL for an APY. I haven't seen your TVL.
Yeah.
50k okay lah.
But most of it is like hooks, and then this one is really. See?
Faiz, I sent you a new one.
AI agents, delta neutral liquidity mining. Oh.
Basically mining delta rebalancer.
Are you using those for yeah. Sorry for the delay, guys. We're going to start very soon right now. So could you please everyone take a seat? Yeah. So just for context for people who are new, yeah, the screen on the right is not working. So we're going to use that screen over there. And so without further ado, I'll pass the mic to Orkun, who is going to be sharing the main topic of today, pushing limits of Bitcoin and ZK Rollups. Over to you.
Hey everyone. Yep. Thank you for coming. Today I want to talk about Citrea, and this is basically like a how it works presentation, but it's not so deep technical. So my plan is to go over the presentation, and if you have more questions, you can always use the whiteboard to maybe go into more technical details. But yeah, excited to be here. It's actually my first time in KL, my officially 5th day or something. And it's been fun, yeah. I mean, I've been eating so much food that even right now I'm very full, but yeah, anyway, so starting. I can start. Okay, I can now. Yep, so ZK Rollups. I'm sure most of you are familiar with ZK Rollups from Ethereum land, and they have very actually straightforward way of running, right? There's this sequencer, source sequencer, usually there's only one, which produces blocks. Then there's this prover, which produces the proofs, and then that sends to the Ethereum and then get verified on Ethereum so that rollup state advances to the next point. On Bitcoin it's slightly different because the problem with Bitcoin itself is there is no smart contracts, right, to do this verification that you do on Ethereum. So it's a little different, but essentially the upper part is very similar. There's the sequencer producing block, and there's the prover produce the proof, and then there's the full nodes who basically syncs from these entities or the operators and then also send the transactions back to them. How does the ZK proving work? This is also very primer. Essentially, you define a state transition function, right? I have this inputs coming in, which is the transactions, and I have this function that I apply to the transactions, and then in the end I have a state. So it should be deterministic so that all the computers can do the same thing. If you look to the Ethereum virtual machine, it's essentially a state transition function, right? You input a bunch of transactions, you run the virtual machine, and then you get the output. So very same thing in here. Instead of writing this VM, you have the ZK circuit, which may run a VM inside of it, or can be an arbitrary ZK circuit as well that generates the proof and then eventually creates a receipt saying that I inputted a bunch of transactions, this is an identifier for it, this was my initial state, and this is my latest state. So why do we and other people building ZK Rollups? Because building a rollup is essentially a way to inherit the guarantees of the underlying blockchain, which there are very key guarantees that you are getting from, such as on Bitcoin, such as on Ethereum. But for Bitcoin, just giving an example, you inherit Bitcoin's double spending guarantees. So when you look into the security of this layer ones, you will see that how much money you need to spend to double spend a transaction, right? How much money you need to burn to steal from someone by reverting the transaction. So in random chains out there, this cost is very low because you can just go to the exchange, acquire the token, stake it, and then do this attack. Whereas on Bitcoin, it's been running 16 years, almost without no attack if you exclude the first 1 year. And it accumulated a lot of hash rate, which essentially gives you a guarantee that your transactions will never be double spent. And by building a rollup, we can actually inherit that guarantee without needing to bootstrap our own miner set. The second thing is the censorship resistance. When you send a transaction to Bitcoin, you can make sure that it will land in some time periods. Whereas if you look to the more smaller chains, it's questionable, right? They can easily censor you because most of the time, single entity or a few entities actually control the stake. And the ZK Rollups on Bitcoin also has another flexibility where we can allow any execution environment. We are not bound with the underlying system. Maybe more, again, like an open example to this from Ethereum land is Starknet. It's not an EVM compatible chain, but it runs on an EVM compatible chain. Similar thing in here with Bitcoin, we don't have to inherit Bitcoin's VM, but we can still run on Bitcoin. And the other thing is essentially, if you build a rollup, because of the proofs that you are producing, you now are able to actually build a trustless or trust minimized bridge to the underlying layer. Whereas if you are building a side chain, you always have to have a multisig that's holding the funds on the L1 and issuing an asset on the L2. So why do we put these ZK proofs on Bitcoin? Because we want to get the double spending guarantees, and we want to have Bitcoin as our ultimate ordering layer so that we are not bound to do any other trust assumption to make sure that our money is guaranteed to be safe. And why do we put the data on Bitcoin? This is again for catastrophic scenarios. If the entity running the sequencer disappears, how do you move the state forward? You need to have all the data to keep producing the ZK proofs. So putting them on Bitcoin makes the data both immutable, and also it will be living there forever, because none of the data put to Bitcoin in the last 16 years has ever been lost, so that you can guarantee that this data will exist. A funny example here is, if I'm not mistaken, it is XRP that has 2-week missing data in the blockchain. So you don't actually know what happened in that 2 week, and you trust someone said that nothing malicious happened. So that's actually a very important point for the importance of data availability. It is the only way to guarantee things happened correctly. And if you lose the data, you lose the correctness. So Bitcoin allows us to keep the data there all the time. Another thing that we are applying here, also some other Ethereum rollups apply, is called state diffs. So putting data on Bitcoin is nice, right? It has all the advantages. But the problem is Bitcoin is too expensive to put all the data. So we need to find a way to compress this data as much as possible. And state diffs are very good for it. So imagine that I'm sending money to one of you and you are sending to the friend. And we are generating a proof that all these 2 transactions are happened correctly. So when I go to the Bitcoin, if I put the proof, then the execution is guaranteed, right? All I need to know is who has the money right now. So do I really need to put all the data, such as saying that I sent money to you and you sent to the friend? The first transaction is irrelevant here because it's already spent by the other party. So I don't need to put that data back to Bitcoin. Instead, I aggregate these transactions and say that this is the difference and this is the proof of execution. So I lost 1 money and that friend gets 1 money. The intermediary, not important because we already proved it and we don't need that data. So this allows us to essentially compress the data a lot so that we can get cheaper transactions that's running on Bitcoin. And the ZK proofs, another advantage is that you can essentially prove anything, any arbitrary execution, right? So you are not bound to the Bitcoin's own VM or own script language. You can build any VM. As long as you are able to prove that VM, then that's good. You will have a functioning system on Bitcoin. Yeah, so again, the main problem is that all these Bitcoin layer 2s that's been launched over the years, quote unquote layer 2s maybe, there's this problem that you cannot ever solve, how to bridge Bitcoin from Bitcoin to this system and then bridge back without having so much trust assumptions. So when you look to the Ethereum rollups, where actually the rollups originated in Ethereum almost like 8 years ago or 7 years ago, there's a very simple way of doing it. First, you need to build a ZK proof verifier in smart contract, right? You need to be able to verify the ZK proof. So that's easy because in EVM you have solidity, you just code it and then it works. The second, you have to have a smart contract that actually keeps the state and then records the state update. So whenever the proof is sent, it has to update itself saying that this is the latest state I have in my mind in the VM. This is also easy on Ethereum because you have storage variables that you just save the state root and it's done. And the third is, while user wants to withdraw, they should be able to send a proof saying that I have the funds, let me withdraw my funds. You can again do it because it's very easy to verify a Merkle proof on EVM. So on Ethereum, this settlement logic of the rollup is easily solved. But when you look to the Bitcoin, because the lack of script language on the L1, especially a string complete script language, no one was able to build a ZK proof verifier. And the second point is because Bitcoin is UTXO based and it doesn't have something called covenants, it cannot maintain a state. Basically, you cannot go to this block and say that what variable are you holding to a transaction, because that transaction is essentially stateless. It only knows how to spend. It doesn't hold any other value. So how do we solve this problem? We solve it with something called BitVM. Who here actually about BitVM or read about it? One person? Okay, so maybe I can explain this a little more, maybe on the white paper as well, whiteboard as well. So yeah, essentially the problem on Bitcoin was you have the rollup and you have the Bitcoin. When you send this transaction, which is the proof, Bitcoin doesn't have any logic to verify the proof on itself, right? It just looks to the data. What does this data do? I don't have any idea. So the BitVM came up around 2 years ago. We are one of the core contributors of it. It evolved over time. It has BitVM 1. We are building BitVM 2 right now, and it actually got audited and production ready. And now actually contributors start to build BitVM 3, which is more interesting version but more complicated. But the core idea is Bitcoin script doesn't allow for Turing completeness, so you cannot do for loops or anything. So you can just have very basic things such as summing up two numbers and then checking if they're equal. This is it. But the funny thing is this is enough to build a ZK verifier, because ZK verifier is just summary and then multiplication. And if you do enough summary, you can reach to a multiplication, right? So the contributor said, okay, let's just build a ZK script, ZK verifier script, which is this long. But when you try to execute this script on Bitcoin, Bitcoin blocks are not that big, right? This script is too long. It is around 4 gigabytes. It's actually dropped down to 1 gigabyte, but the block is only 4 megabytes. So there's no way to fit this transaction back into Bitcoin. And then the contributor said, okay, what if we divide this verifier into thousands of pieces where every piece is very, very small so that they can fit into Bitcoin block. And then we make this prover sign every input and every output from one piece to another piece. So this essentially gives us a way to verify that someone publishes thousands of signatures and a single input. And then you can actually see that if the ZK proof verification happened correctly in all the steps, because if any step this operator give us a malicious output, this next script will not be running, right? It will give an error because the signature doesn't verify or the script doesn't verify. And then this is basically the core idea behind BitVM. Instead of trying to verify this whole ZK proof in once, let's divide it into 1,000 pieces and then publish off-chain and then see if someone spots an error. And then let's give it a three days window. And if someone spots an error, they can just take this script, run it in Bitcoin. And if Bitcoin doesn't verify, then you can go to the operator, to the prover, say that, okay, you are trying to trick the system and be malicious, so I will slash your stake. This is the main idea behind BitVM. And this essentially allowed us to build this optimistic ZK verification framework. So instead of verifying ZK proof at once, we do this in an optimistic way. If anyone spots an error, at least a part of it, to make sure the result is correct. While doing this, we have the signatures over here, right? Every step is signed. So with signatures, we can also move the state from one to another, because every signature essentially signs an input and output. Then you can use this in the next block saying that, look, this is signed for this block number. Now I'm at this block number, so the state is actually moved. So essentially we solve this two main problem that Bitcoin doesn't have, verifying a ZK proof and holding a state by using this technology called BitVM. And this is also basically a very basic diagram of how the BitVM works, because this process is quote-unquote heavy, that you need to wait 3 days before the settlement. You cannot do this for every single proof you send, because the proofs are sent maybe once in every hour. So what we do is we send those proofs for maybe a week, and end of the week we aggregate the proofs and say that to Bitcoin, go to the BitVM, this is the proof, verify it, at least wait 3 days to verify it. If no one challenges, just accept it as the truth. And the BitVM and the Bitcoin itself now has an idea on the rollup state by basically seeing that, okay, this has happened, no one argued about it, so this is the correct output, and I will facilitate the withdrawals to this side from this side system back to Bitcoin, and everything is actually mathematically proven under one-of-n trust assumption. As long as one party is watching the chain, they can put the fraud proof to verify ZK proof. If no one did, then this means the system is secure. What is the ideal way of doing this? Definitely not this. It took us 2 years to build this, and it's live on testnet right now, but we literally started building it 2 years ago, and the engineering work still continues today. So the ideal scenario will be having one of these two opcodes on Bitcoin. One is OPCAT, maybe you heard about it. It's essentially a concatenation opcode that takes two strings, smashes them together, and then puts back into the script. And you can ask, like, what is this useful for? But if you look carefully, you will see that a Stark proof verification, which is type of ZK proofs, is essentially only Merkle proof verification. And if you are able to concat two strings together, you can do a Merkle proof verification. So if we had this OP code on Bitcoin script, then we don't need to do all these tricks. We could instead just verify the ZK proof, same as this hypothetical OpZKP opcode that lets us just verify a ZK proof. But we don't have those things today on Bitcoin. So we had to innovate, and we come up with this BitVM. So there are some misconceptions about ZK Rollups. They're probably like, this is primarily for Bitcoiners because they don't know about these technologies, right? They originated on Ethereum. Obviously, they say, for example, sometimes you don't know what's being proven, right? It's private because it's ZK. ZK systems can be private, but they don't have to be private. Most of these ZK rollups today, you have all the transaction data, and you have the ZK circuit. So they are definitely not private. There are some chains that makes it private, such as Elio, such as Aztec, right? Such as Zcash. But they're intentionally making it private. But for the rollups, most of the rollups, they're not private. They are just there to compress transactions. And again, the trusted setup ceremony comes with the rollup, comes with the ZK circuits. Actually, like the older types of ZK proofs had this issue, whereas the new types of ZK circuits, such as Stark proofs, they don't require a trusted setup, so it can be fully trustless. And ZK circuits are hard to code and audit. This is also false. This has been true 3 years ago when we first started our company and started to build ZK products. We were writing circuits in a language called Circum, which is fully specialized in ZK circuits, but it was very, very painful. Then now this new VMs came up, such as RISC-0, such as Succinct SP1, and then said that, okay, you can just write Rust code and I will prove it for you. And they were also quite slow like 2 years ago, but right now they're extremely, extremely simple to run. You don't need dedicated hardware at all. You can just like prove all this Ethereum blocks or Base blocks or Citrea blocks under a few seconds on a decent machine. Even on mobile phones, if you have an optimized VM, optimized circuit for it, you can do it in under a second, essentially. So they are definitely getting more and more faster every single day. And there's only one entity running the sequencer, which poses a risk. That's true. That definitely poses a risk in terms of the liveness. If the sequencers goes down, which is the block producer, then the chain stops. But that doesn't definitely come with a trust assumption. Your money can never be stolen, even if the sequencer is malicious, because everything is protected by the ZK proof. So why do all these hassles, right? If you look to the Bitcoin ecosystem today, the problem is there are a lot of custodial solutions to build privacy, but with a custodial solution, you cannot have privacy, because if someone controls your funds, whether or not they are able to see your funds, they can seize your funds, which is not ideal, right? If you want to do a Bitcoin payment today, most of the wallets are custodial. They are connected to a single node, or your keys are controlled by them, which is not ideal. Same for borrowing against your Bitcoin. Same for buying Bitcoin. Like, how do you buy Bitcoin today? The only way is to use a centralized exchange, which you have to dox yourself, give your passport, give your ID, and then give your money's control to try to buy Bitcoin. So these things are not ideal, but with Citrea, you can do all of these in a non-custodial manner without needing to submit your ID to anywhere, or without needing to give your keys to someone. You can just own your MetaMask wallet or whatever wallet you are using and do all of these things on Bitcoin. So how to build on Citrea? This is probably more important than the rest of the slide. So we really optimized for it when we started the journey, because our background is coming from developing on EVM chains such as Ethereum. And then we know that having a decent tooling is very, very helpful to build applications. If you go to a new chain today that is a new VM, it comes with a lot of problems. So we decided to build Citrea as a fully EVM compatible chain, so that if you are developing an application today on Ethereum, Arbitrum, Optimism Base, whatever, you can deploy that on Citrea, and instead of working with ETH, it will start working with Bitcoin without you to change anything else. And then it has all the developer tooling with support from Alchemy, Layer 0, Gold Sky, Redstone, all the other names that you are knowing from the Ethereum lands. We have an ecosystem support. Essentially, we support all the teams in the ecosystem at basically the max we can do. But separately, we have this hands-on incubator and accelerator program that's run by Jason. So it's essentially a very, very hands-on program for us to work with the teams to move them from the 0 to 1 stage. Because when we started the company, we also realized that finding money in this space is easy, finding grants is very, very easy. But if you are a new developer who is building something, there is something more important than the money, which is the support you are getting from the team that you are building on. That can be marketing support, that can be introductions to the VCs, that can be introduction to the liquidity providers. And this program, we try to do all these things, but it comes with a trade-off, right? We only have very few people in our team who can focus on this. So it is hyper-created. We only work with 7 teams right now. We are looking for more, but 99% of the projects, we support them on the ecosystem, not on the incubation level. This is only for basically the dedicated teams who comes up with their unique ideas and then needs a specific support from us that, and after this point, if we have a conviction, we definitely support these teams all the way. And if you want to build a Bitcoin application, Citrea is essentially the only place that you can build a trust minimized Bitcoin application. You can build a Bitcoin application maybe on Ethereum using RepBTC, but then it's essentially no different than holding your Bitcoin on Bitco custody because it's a fully custodial asset. So this is the only way doing this trust minimize. And our testnet has been live for a little over a year right now, and we are looking to deploy mainnet very soon. These are the 2 links that you can check, and on the web page you can find all the other relevant documentation and the white paper for our bridge too. And on the Twitter you can see all the frequent updates from our ecosystem and our partners and our basically development process. So if you have any questions, technical or untechnical, happy to answer those.
So thank you, Orkun. So right now we're going to go to Q&A. So who have a question?
GM, I think thank you for sharing. I think it actually is pretty valuable. I think it's pretty interesting that your mechanism is like, correct me if I'm wrong, it's a mixture of optimistic plus ZK instead of something like we observe on Ethereum layer 2s. They are either fully ZK EVM or fully optimistic rollup, waiting to be challenged on chain. But something that I want to ask is about the economic of it. I'm more of the app engineer instead of a ZK engineer. So we have developed on different chains before. Let's say like there are some ZK EVM chains like Linear. I observed that their gas fee is actually pretty high, like something like 1/4 of the gas fee of Ethereum. It's actually not too much of a saving when we develop on Linear. And compared to something like Scroll's gas fee is actually much lesser than even compared to base, like 0.00023 Gwei, something like that. So at your opinion, which one is sustainable? Like if you are committing proofs or ZK proofs to Bitcoin, right? How much of a gas fee you charge will be reasonable for the entire ecosystem to be sustainable?
Yeah, that's a very good question, and that's definitely an important factor to also like to choose which kind of application you want to build on which chain. For Citrea's case, obviously like every decision you do comes with a trade-off. Today, I don't know the exact mechanics of Linear and Scroll, why they differ so much, but the case is likely that the Scroll doesn't commit their blocks back to L12 frequent compared to the Linear, or their proof system is different. I'm not sure, but we choose to settle on Bitcoin because we want to get Bitcoin security, right? We don't get Ethereum security, we get Bitcoin security, which is superior than Ethereum security if you look to double spend resistance and everything. But this comes with a trade-off as well, because we are sending all the proofs and data to Bitcoin. It is more expensive block space than Ethereum. So the gas fees are definitely higher than the Ethereum L2s that you look for. But if you want to build a Bitcoin application who benefits from Bitcoin security, then there is a quote-unquote tax coming associated with it, which is charged by the rollup. One optimization that we do is the state diffs that I mentioned. If you are building an application, let's say a DEX, right, a Uniswap v2 DEX, if everyone trades the same pool, then the transaction becomes cheaper and cheaper because the state diffs become more aggregated. If 5 of us do a transaction on a pool, whereas there's 1,000 people doing transaction on a single pool, you still need to record the exact same data to Bitcoin. So you essentially divide the transaction cost by 200 by getting more usage. So we definitely start with a more conservative estimate on the fee rate side so that it's little expensive. But as we scale the usage, we want to just reduce those fees to match what we are sending to Bitcoin. But the rollups operate on a very thin margin already, so these fees are not taken by us or anything. It is 99% going to the Bitcoin miners, and then there is basically one buffer to keep it safe. But the gas fees, we expect it to be maybe more closer to the Ethereum than Ethereum L2s.
Super. Thank you.
Hey, thank you for your sharing. The question I have is, so regarding OPCAT, from what I understand, it's quite a topic
Yeah.
that's been discussed. You know, a lot of people agree that it's to be added. A lot of people don't agree. So I believe BitVM3 probably doesn't use OPCAT as well. But so is there any plan, or what's your plan on like pushing OPCAT maybe?
Yeah.
Or like, yeah.
So the BitVM is essentially the mechanics to verify the ZK proofs, right? And with OPCAT, you do the exact same thing in a different way. But this is not everything that consists the bridge, right? Once you verify the proof, you still have a lot of work to do, such as how you dispense the withdrawals, right? How you do the withdrawals, how you do the deposits. So our software is called Clementine, is basically the thing that does all of these. But in its core, it uses BitVM as a verification engine. But the architecture is modular, so that if tomorrow people want to agree that, okay, we should have OPCAT, it's easy for us to replace BitVM with OPCAT. We can probably do it in a month or two. But the Bitcoin consensus is extremely slow compared to the Ethereum. You mentioned like Fusaka upgrade, right? So they do few calls with Ethereum Foundation, and everyone thinks it's a good update, and then they update. Whereas on Bitcoin, the latest fork was 4 years ago. So it is like in Ethereum, I think they ship once in every 6 months or once in a year. But on Bitcoin, it was 4 years ago, and no one ever know if there will be another upgrade or not. So OPCAT is definitely more controversial because some people think, like us, having a ZK verification is helpful, or other things that you can do because it increases the function of Bitcoin. Whereas some people think that the more we add, the more risk we are exposing to Bitcoin. So it's definitely an just like a discussion point. But Bitcoin consensus, once something is started to be more clear, it still takes around a year to realize. So we definitely have time to swap it. But right now the architecture is towards BitVM2 with more modularity to add more stuff.
Thank you. One more follow-up question. So this is more on the application side of things. So you've mentioned that you're looking for more application on Citrea, right? So is there any particular application that you want to see on it that you think will be a great addition to Citrea that works really well with the Bitcoin ecosystem?
Yeah, I think generally the verticals we are looking is like DeFi, consumer, and payments. In the incubation program, we also have the similar things. Yes. Thank you. So in the incubation, we also have mainly these verticals, the DeFi, consumer, and the payments. We're also looking into more like CDeFi space where everything is actually on chain, but maybe there are some risk managers or curators running the strategies instead of users. So generally the DeFi space is interesting for us. Like we have Bitcoin-backed stable coins, we have money markets on Bitcoin, but definitely like as something unique comes it, we don't look, oh, this is not DeFi, we don't want it. We definitely look for more broader space, but the focus is definitely DeFi, consumer, and the payment applications.
Yeah, this mic is not working, so I'm just going to shout. Any more questions?
Great. Okay, thank you everyone. Yeah, on.
Yeah, I see like perp trading is like. I see like. Does it work?
For recording.
That perp trading is like one big thing at the moment. Is this possible with Citrea as well?
Yeah, it's definitely possible because, like I said, it's like an abstracted layer on Bitcoin, right? If you want to build a perp text that uses Bitcoin as the collateral for the trades, then you can do it on Citrea because it's a fully EVM compatible chain where you can do all the things you do on Ethereum and you do on Bitcoin. So you don't have to basically think about anything related to Bitcoin at all. You just build on Citrea, and Citrea gives you all the access to Bitcoin liquidity and the security. So definitely something like perptex is possible.
Okay, thanks.
Any more questions?
I think one more here.
Because it is a Bitcoin rollup, right? So how do you actually breach the Ethereum assets to your rollup?
Yeah, so the main asset of the rollup, the gas token of the rollup is Bitcoin. So the canonical asset comes from Bitcoin. If you want to breach from Ethereum, you can use any interoperability solution there because it is, again, fully EVM compatible, right? So right now on testnet, we have Hyperlane and Layer 0 deployed. So if you want to use them, you can just use it. And there was one, basically, an actually undergrad project that built on us, which verifies the proof of Citrea on Ethereum as well, instead of just on Bitcoin, so that you can have more trust minimized interop even with Ethereum as well. So if you want to go with maybe more trust minimized, then you can definitely take our proofs from Bitcoin and verify on Ethereum and get the similar trust minimized bridge. But if you want to just, like, if you are happy with the current interop providers such as Layer 0 and Hyperlane, it's already deployed on testnet, so you can just bridge any asset you want to Citrea and the other way around.
I see. So do you have like multiple representation of the same asset, like if that is breached by Layer 0 and if that is breached by
I mean, it can happen on every network, right? Today, if you are bridging USDC to Arbitrum, there's native USDC on Arbitrum, so you just use it. But if you are crazy, you can just deploy your own bridge and then make your own USDC on Arbitrum. So it's definitely possible to have multiple representations. For the core assets, we bridge ourselves. So we have canonical USDC and USDT bridge from Ethereum that uses Layer 0. But if you are not happy with Layer 0, you can build your own USDC bridge with Hyperlane. And if people want to use it, they can always use it. But especially for these main two assets, we have our own canonical bridge to not to basically fragment the liquidity.
I see. Thank you.
Yes.
I have another question again. So I see there is only one sequencer, right?
Yeah.
So it's very central. And for other ZK chains, there's always the argument, okay, you could censor transactions or you can reordering and do those kind of stuff. So how Citrea deals with these issues, and is it maybe planned to decentralize more?
Yeah. So with the reordering of transactions, we have few mechanisms to guarantee the ordering until the proofs comes, which is called sequencer commitments. I don't think there's other rollups doing this, or it's on the documentation, but for the decentralization, yeah, I agree. Like the central, having a single sequencer, always a risk. It's better if you have multiple, but it's rather like an engineering problem than something else. We just need to sit down and build this infrastructure, but we first want to ship the mainnet with essentially with the MVP and then build out this infrastructure. So yeah, it's definitely in the plans. There are not many examples, but there enough research to figure out how to build this. It can be a rotating sequencer set, or it can be actual consensus running between the sequencers. But like I said, it's more like an engineering problem rather than a research problem.
Okay, thanks.
Any more questions? Once, twice.
Yes. You have enough?
One question regarding the prover that Citrea is running right now. what's the current hardware requirement for like running a prover for
Yes,
ZK?
so our prover system is essentially using RISC-0 ZK VM, and we are using Boundless as a marketplace to pull the ZK proofs. So we are not actually running our own prover right now. We are requesting it from Boundless, which is a decentralized marketplace. But I don't know the exact specs, but I know like when we started 2 years ago, we were very coming behind of the real-time transactions while proving. Right now we are very, very close to having real-time proofs because of the improvements in the system. But I don't know the exact system specs, but I can check it for you.
Thank you. Yeah, I think they have very strong computers.
Yeah, they have
Yeah.
very strong
Yeah,
computers.
thank you.
Last call. Any questions? Counting once, twice. Okay, so let's give a round of applause to
Thank you.
Orkun. Yeah, we're going to take a very quick group photo, probably right over here. Then after that, we're going to have pizzas outside. We are ahead of time, so we have this space until here 9:30, outside until 10. So yeah, let's take a group photo right now.